5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Reusable satellites are our topic this week. Why they make sense, what the economics are, and other related questions. Our guest is Brian Taylor, CEO and founder of Lux Aeterna, a Colorado-based startup working on exactly this. Enjoy. My name is Raphael Rodkin. I'm the founding partner of E2MC, Earth to Mars Capital, a venture capital investor in dozens of space startups worldwide, such as being a part-time podcast host. Just as a reminder, this podcast is for informational purposes only. It does not reflect any view by E2MC, and nothing should be taken as investment advice. Before we start, a quick favor. If you do enjoy this podcast, please leave us a 5-star review on your favorite podcast app, such as Apple or Spotify. It does help other people find the podcast. Now on to today's episode. Hey, space enthusiasts, welcome back to another episode, Space Business Podcast. My guest today is Brian Taylor, and he's the founder and CEO of a space startup called Lux Aeterna. Welcome, Brian.
Thank you very much. Thanks for having me.
It's my pleasure. And we usually start us with the elevator pitch on your company, please.
Yeah, absolutely. So we're building re-entry capable reusable satellites with the goal of getting to fleet operations, which really deals with a lot of the problems that we have today in manufacturing capabilities for satellites. So it takes a long time to build satellites and kind of get to orbit, assuming that launch is no longer the bottleneck. And so we build vehicles that are capable of on-orbit operations as well as re-entry, recovery, and refurbishment. And really, once you layer that in with many vehicles, you get to fleet operations. And that's really the key unlock to scale that we see in the future of the space industry. So that's the overall elevator pitch. Happy to go into specifics as you see fit, Raphael.
Okay, yeah, we'll definitely come back to that concept of fleet operations and fleet management. Yeah. That sounds fascinating, and I haven't heard it in that sense before. Yeah. But we'll talk about that. But let me maybe ask you, Lux Aeterna, why that name?
Yeah, so it's Latin for eternal light, and so really it's a nod to the light that exploration kind of provides to all of us space nerds and the people of Earth, and the eternity of that is a nod to the reusability of our satellites. So really it's getting reusability out of a thing that provides a lot of light for space nerds like us.
Gotcha. Okay, makes sense. All right. Let me also ask you, how did you come up with that, right? I mean, I know you have a space background, sort of like what motivated you to start this? Well, maybe tell us a little bit about what your background in space is for our listeners. And that, I know with that background, you could have done many different things in space. Like what motivated you to do this specific thing?
Yeah, totally. So my background is about 15 years in aerospace and satellites, from aviation and aircraft to satellites themselves. I was on the Starlink program at the very beginning of that program, and we went from kind of what used to take 3 years to building 6 satellites a day. Did all the structural qualification for those satellites and have a lot of really great anecdotes and stories from that time. It was definitely very Wild West with how fast, we got that program off the ground. And then I did aircraft and Starlink aviation, putting Wi-Fi on planes, and then went to Amazon's Project Leo, so more high rate production of satellites. And then most recently, I was at Loft Orbital. So across those 3 specific companies or experiences, I got this really good exposure to the pains of satellite manufacturing and a couple of different ways of solving that, both on the technical side as well as the business model side, and didn't really see those things being solved. And so I started looking at kind of, what does the future of launch look like and how does that affect satellites? When SpaceX came out with the rideshare or transporter program, a whole bunch of satellite companies kind of sprouted up. And that was because you could go to an investor and say, I'm going to launch on a rocket in 2 years, and it's a SpaceX rocket, and they would trust you. And that means you can get funding to go do some kind of nifty new satellite application. That doesn't currently exist from the satellite to the payload. So if you have a nifty new payload or a nifty new business case, it's actually pretty difficult to get a satellite that matches that in kind of a few or even in constellations. And so, we really looked at kind of what could we do on the satellite side to enable new use cases of payloads. And with launch prices where they are, we started looking at kind of a slightly less optimization of the mass of the satellite because launch prices are less than they used to be. So we put a heat shield on the satellite, and then we designed the satellite specifically so that the entire thing is fully reusable. And so you get reentry and then you get reusability, but the goal is actually to get to this fleet of satellites, right? And so that was really informed by my time at SpaceX and Amazon and Loft, and the pains that we had in terms of getting satellites to the launch pad much quicker than the current kind of 2 to 5 years, depending on if it's commercial or defense. And so that's really what kind of struck me as the why now was based on the launch market and these pains in the satellite industry. And so, yeah, launched the company about a year and a half ago, and our first launch is Q1 of 2027, so coming up here in less than a year, and we're really excited about that.
Cool. Let's flesh these out a little bit more because this is
Yeah,
fascinating. So, I mean, if I understand correctly, you're basically saying in getting a someone starts a space company and maybe it's a space applications company to do something interesting like, some type of interesting remote sensing or satellite communications, direct to device, whatever it is.
yeah,
I think what you're saying is basically SpaceX, at least for now, has taken a little bit, has made the launch less constrained. Well, actually, I'll actually ask you about that in a second.
yeah,
Um, and you seem to say the pain point, the constraining factor is actually on the spacecraft side and specifically the time it takes. Is that, I mean, we always kind of have to kind of go where the puck is going to be, right? Like the famous Canadian hockey analogy is sort of, you think this is going to be the case for quite a while? Because I mean, my day job is in VC, right? And have been getting pitched many spacecraft companies, right? And there's obviously people who have a lot of money to build up capacity now. Are you still worried about this constraint? I guess you are.
I mean, I think that shows that the problem isn't solved, right? If people
Yeah.
are continuously looking for different solutions to try and solve that problem, it's not solved. And so there's different technical ways, different business model ways to try and solve that. We go about it in a certain way where we're absolutely addressing the down mass market, so hypersonics test and
Hmm.
materials testing and in-space manufacturing. But really, we believe that we're building an infrastructure that's better for really the scaling that is to come. So I think if we assume that the space industry is kind of static where it is right now, then kind of disposable and attritable kind of works out okay. But as you scale that up and want to get from 10,000 satellites a year globally right now to 100,000 to a million, you really need to look at a different way of doing that than building every satellite for a 5 year timeline that then demises in the atmosphere afterwards. To get to that really large scale, we think that reusability is absolutely critical.
Okay, let's talk a little bit of, like specifically about your product. So what does it look like? How big is it?
Yeah, so it broke up a little bit there. So you asked about the product, right? Like
Exactly.
about our satellite. Yeah, totally. So we make a re-entry capable satellite. So it's more so a satellite that operates on orbit rather than, say, a re-entry vehicle that is more specific to kind of just the re-entry capability. To do that, we fundamentally design the satellite differently. So usually on most satellites, you have a cold side and a payload side. And the cold side in low Earth orbit, faces deep space, and that's how you reject all of your heat. We take that side and we cover it up with a big insulating heat shield. And so because of that, thermally on orbit, we have to operate the satellite differently. It still works, it's still fine. You just have to know that kind of going in, and how you're going to operate it differently, with sun pointing and orbital mechanics and kind of all those different types of things. And so we have an integrated static rigid heat shield. And that is kind of fundamental, is that the heat shield itself doesn't have big complex mechanisms in order to be able to survive reentry. It is integrated into the structure of the satellite bus, and doesn't have inflatables, doesn't have mechanisms to do that. And that really makes it a very robust system that we can test on the ground. And then tucked behind that is all of the satellite components like ACDS, flight computer, battery, things like that. So our first vehicle is Delphi, which is about 200 kilograms. And we've got about a 30 kilogram capability for payload. And then we'll be scaling up to our next generation vehicle, which we haven't necessarily announced any of the specific details on that. But Delphi is very much our technology demonstrator and the first one that's flying in Q1 of next year.
Okay. And so this satellite could then be like adapted to all of the standard use cases in terms of the payload, communications, remote sensing, and so forth.
Yeah, so Delphi specifically is our technology demonstrator that has payload capability. And so we've matched up payloads that align with our first mission and that ConOps, right? And there were scope reductions on the performance of the vehicle in order to get to launch and orbit and reentry as fast as possible. So it can't necessarily do all of those things. Our next generation vehicle will be able to do all of those things, but yes, it can do in-space manufacturing, it can do Earth observation, it can do comms, it can do ISR missions, it can do defense-specific applications, things like that. It can do on-orbit servicing. That's the more capable vehicle is the next generation one.
Okay. Gotcha. And like, yeah, let's talk a little about, you started actually already talking about how this is different from other satellites, and sort of the most obvious thing is the heat shield. But with the heat shield, so it seemed like you said, like this is established technology. It's like a type of heat shield that has been used
Yeah.
before.
Yeah, so the heat shield itself on Delphi is very similar to what's used on other reentry vehicles. And we lean a lot on our partners from NASA, to through our Space Act agreement to take advantage of the work that they've done. We're reinventing the wheel on the vehicle itself. So all of the subsystems that we can stand on the shoulders of giants, we do that.
Mhm.
And so we're not necessarily reinventing the wheel on all the different subsystems. In parallel to that, we are doing development of our own reusable heat shield material that will be used on the next generation vehicle. But that's not necessarily in place for this first vehicle. Really reduce risk as much as possible on the reentry, case of this first mission, and just learn how to fly, a spacecraft through the atmosphere. That's kind of the key objective.
Yeah. I think so. It's funny when you say like similar to other re-entry vehicles, right? Just like to remind our listeners as well, that correct me if I'm wrong, but there aren't that many, right? I mean, at least ones that actually have come back. I mean, it seems like this is substantially still a capability a few nation states have demonstrated, plus WADA, unless I'm forgetting something.
Yeah, no, you're correct. So NASA has a lot of examples of reentry vehicles, and so they've developed this heat shield technology for that. There's other commercial providers that use the same, heat shield, and then kind of once you get to reusability, that's where you get into the realm of highly proprietary and kind of bleeding edge, on the heat shield development front.
Yeah. Yeah. Okay. And so apart from the heat shield, is there something else that, is different from quote unquote normal satellites you have to keep in mind here? I mean, I don't know, is there like extra propulsion, extra delta V you need for the re-entry, that type of stuff, or something else that looks different subsystems which are slightly different?
Yeah, totally. So one of the big ones is that we have retractable solar arrays. So on normal satellites, all the solar arrays go out and they stay out, and the mechanisms and the structure are built to support that. We have a retractable solar array that goes in and out. It'll actually do it many times over the course of the mission because it makes propulsion maneuvers easier if your solar array is in. And so we get to take advantage of that. But for sure, we need to bring that solar array in before we, come back for reentry. So, it's important to us that we're not jettisoning anything from the vehicle, and we're really taking advantage of the refurbishment and the reflight on all of the components, not necessarily just the very, very expensive parts of it, because really it helps us on the supply chain of just not having to source a new solar array or a new, relatively trivial component.
Yeah. Is that something was that like the retractable solar arrays? Was that something easy to solve? Like, for example, could that something you could work out with your suppliers, or is it something where you have to develop an in-house solution?
We've developed the in-house solution. There's not very many suppliers. There's definitely a lot of mechanisms and things like that, but we've developed this solution specifically for our use case and for our vehicles, and especially to survive the reentry environment as it comes back. So yeah, we developed that in-house.
Okay. And then, so if all goes well, so I guess, okay, satellite goes up, does its mission, comes back
Yeah,
down. I guess there's probably some sort of refurbishment
yeah.
happening. Is there actually any components which have to be completely replaced other than propellant, obviously?
On the first vehicle, it's really the heat shield, which is an ablative, one-time
Yeah.
use heat shield, and which is kind of part of the deal and why we go to the reusable in the future. I mean, the goal here is that the refurbishment cannot look like the space shuttle refurbishment. Like that was called refurbishment, but really they just
Yeah.
rebuilt that vehicle almost every time, and it was extremely expensive, had this giant standing workforce. And so obviously we've designed the vehicle in our mind will not take nearly that amount, and will progressively get more and more to a faster turn time on refurbishment, and we'll do that through block upgrades, as we learn more as we fly it. So
Right. And by the way, I haven't asked this specifically, but I'm assuming we're talking about primarily or exclusively LEO satellites here, right?
for this satellite is LEO. We can design our vehicle for other orbits and for cislunar, but the Delphi vehicle is specific to low Earth orbit, and we will most likely do vehicle configuration changes to cover other orbits.
Right. I mean, I'm obviously asking because I mean, if you go, let's say to go to GEO, right, that has implications both for the reentry profile as well as lifetime radiation exposure and things like.
Yeah, exactly. I mean, for sure, we started with Leo. It's the most accessible and it has the highest market. And it's the accessibility that we have on launch for that is really the key without having to go, raise our own orbit or do a kick stage or things like that. So those are other applications we will definitely look at in the future. But right now we're focused on low Earth orbit.
Okay. And so if all goes well, I mean, how many times you think those satellites might be reused?
Yeah, so Delphi specifically is it'll probably be less than five total. But our next generation vehicle, kind of the sustained production flight count is 15 reentry cycles or 15 years cumulative time on orbit is what that vehicle is being designed for. And that really gives us the right kind of napkin math for cost amortization and kind of like reasonable physics.
Okay. So obviously, I guess the other thing we talked about replacing subsystems and stuff and
Yeah,
refurbishing, checking the heat shield. But I guess the other idea is that the payload obviously typically would get
yeah,
upgraded, right?
100%. Yeah,
Okay. So I was trying to figure out sort of like very roughly, and I'm sure you've run these numbers. If all of this goes well, and suddenly the non-payload subsystems get amortized over whatever it is, 10 flights, let's say for easy math, rather than one flight,
yeah.
what kind of savings do you think customers can achieve here?
Um, I think, it's a pretty wide range based on kind of hitting the targets that we want to hit, but it's somewhere in the 5 to 10x cheaper than kind of doing an attritable bus or a disposable bus. Because one of the big parts is you don't actually buy the satellite as a customer. You buy space as a service where we are actually operating the vehicle for you, and kind of operating that payload. So it really reduces a lot of the costs of a customer that may, in other instances, have to buy a satellite and either learn or pay somebody else to actually operate it in space.
Okay, which I guess that comes to the concept of fleet operations, fleet management, then, right? Is
Yeah.
I guess in a way, I'm having some of these conversations with similar people in other episodes, and they're like, "Oh, we're a satellite bus company." Like, I guess you don't want to be called a satellite bus company. You are a satellite, like a fleet operator.
We're a fleet operator. Yeah, exactly. Yep. And likely sometime down the road we may split and be more purely on the manufacturing side. And then there's other operators. But for right now, like I said, we've designed a fundamentally different satellite. So we really need to be the operators to cover integration, operation on orbit, and then reentry as well as refurbishment. But yeah, we are a fleet operator, and really excited to kind of increase the numbers of our vehicles in the future.
Okay. Um, let's talk about, I was going to say, let's talk about the market. But sorry, I want to ask you one final, it's not a tech question, but it's sort of related to, I guess, your architecture.
Yeah,
Since you're bringing something back, this brings up the whole like regulatory question. I mean, some people have had headaches with that, right? Like WADA on their first
yeah.
attempt to bring something back. So, I mean, you're talking about potentially bringing like a lot of stuff back to Earth.
Hmm.
How do you
Yeah.
see like the regulatory environment evolving and like where this is going to happen and all of this?
I mean, it's definitely evolving very fast. Other commercial companies have done a lot of trailblazing on that front, but it's still very much changing now. We have to get a license for the reentry part as well as the point on the Earth where we're actually going to touch the ground or land in the ocean. All of our vehicles land on the ground. Our first launch is going to land in Australia. And so we have, regulatory licenses to go through that. We're going through that process. It's long. We want it to be shorter, but it's not necessarily that cumbersome or difficult to do within our existing engineering processes, documentation, and things like that. So we're excited for that to continue to evolve and get more and more efficient. But right now, it's kind of learning as they go, and our regulators and regulating bodies, as well as learning as we go, being a very young company, kind of getting into this game.
Gotcha. Okay, let's talk a little bit about sort of the market and the commercial use cases. And I mean, the overarching question
Yeah.
was, why we use satellites, but you started answering that, and we kind of got into
Yeah.
the concept of fleet management, accelerating
Yep.
time, and making sure there are enough satellites around to satisfy market demand. Um,
Yep.
but tell us a little bit about the other sort of, intrinsic use cases of reusable satellites.
Yeah, so one of the things right now is that most low Earth orbit satellites are designed for 5 to 7 years in space. And that is based on the lowest common denominator of what is going to fail first. Sometimes it's fuel, usually it's clock cycles on electronics, sometimes it's UV degradation on solar arrays, but generally that's kind of where most low Earth orbit satellites target. When you think about getting additional value out of one of those satellites or a constellation of those satellites, the only knob that we have to turn is making the mission longer. But very rarely have people looked at what if we designed the mission to be shorter. And so there's this period of 1 day to 6 months to 1 year to 2 years to 3 years, where if you actually design your mission architecture around that shorter duration, other things can get a lot easier. So maybe your payload doesn't need nearly as much radiation tolerance, or doesn't need to go through the same number of thermal cycles and thermal fatigue. And you can be much higher risk and lower cost on the payload that you put up because you're only going to be up for, say, 1 year. Now, that's not how we design our satellite, but that means that the payload itself, kind of the world of possibilities can really open up. Another thing to think about is when a satellite lasts that 5 to 7 years, everything on the satellite needs to have a minimum life cycle or a minimum lifetime of that 5 to 7 years. Some components, it's really hard to hit that number. Others can blow past it and it's really easy and they can last in space for 20 or 40 years or something like that. But those all have to align. And when we have a reusable satellite that is capable of re-entry and then we get human hands on the hardware, we can replace the one thing that needs to be replaced without replacing the entire vehicle. And that has huge implications for cost and supply chain. Again, you just simply don't have to rebuild those components that don't need to be replaced instead of one thing kind of taking out the entire satellite. So looking at those lower duration missions, less than say 3.5 years, that's where we really think that when you have strong economics for those mission types, the payloads and the mission architectures will really open up. And one of the key things about that is that when you have a short duration mission, usually you really want a short duration lead time. And that doesn't really exist right now in terms of getting a satellite and a payload integrated and tested and flown. Usually is kind of 2 years best case. If they're all the same, like Starlinks, you can do 6 a day, but they're all the same and you can't do kind of different customer use cases. And so our goal is to really reduce the both sides of launch, right? So you have a smaller lead time, and that's really good application for a smaller duration. So there's very specific kind of defense applications where you want some asset on orbit very quickly, but you only need it there for a short period of time, and then you bring it back down, change the mission application, change the kind of spot on the Earth that it's focused on, things like that. So those are a couple of the specific use cases of why you would go less than 5 years, especially if you can get a much shorter lead time.
Gotcha. On the point you made that some stuff needs to be replaced earlier than other stuff, is that generalizable or can you be more specific? Like, I'm just curious. Is there stuff that tends to break first?
Yeah, so usually the limiting case on the satellites that I'm familiar with is often degradation down below a end of life level for power on the solar array, depending on if you're using space grade or kind of terrestrial grade, um, solar arrays. So that's one thing that can be replaced really easily. Batteries go through a lot of thermal cycles depending on how you design them and how
Mm.
you protect them from the thermal environment. And the other one is kind of clock cycles and bit flips on electronics. And some of those will have, a lot of activity during a mission, during the entire life of the mission, say a flight computer. And then you've got others that are only used maybe in the beginning or when they're in safe mode, like a TT&C antenna and kind of the things that go along with that. So those are some specifics. We've got a model that says these things are going to get replaced every 5 years, these things get replaced every 10 years, etc.
Yeah, gotcha. And then in terms of the use cases and um, the use cases that are driven by that reusable aspect,
Yeah.
whether it's in space manufacturing or some of the defense use cases you mentioned, is there some easy logical way to segment the market, like these markets with regard also to the type of re-entry capable vehicle, right? Because there's what you guys are doing, but then there's people who do like capsules, right? And then there is, I mean, Starship, right? Starship is going to go up and down all the time. So how
Yeah.
do you guys think about segmenting that, and what are the most logical markets for you guys to go after?
Yeah. So the way I would segment that is, are you performing, is re-entry the core value proposition, or is transportation to some place in space the core value proposition? Or is operating in orbit for some period of time and having sustained operations for a long period of time or a short period of time or an adjustable period of time. That's kind of the third case there. So I think that's one way of segmenting it. I think another way to segment it is, do you need your hardware back or not? For sure. And kind of, do you need access to the vacuum of space or the view to deep space or the view to Earth to do that? And are you 50 tons or are you smaller than that? Right. That's definitely another way to segment that. So the way that we think about it is that we're performing satellite missions And the way that we give very good, robust infrastructure to do that is via reentry and reusability, but it's the satellite mission that we actually care about.
Gotcha. And so let me talk a little bit about the business model because 10, 15 minutes ago, you mentioned that you're gonna basically offer space as a service, right?
Yep.
And so this, so what does that mean? That basically means someone wants to operate again, let's say like a remote sensing capability, they're gonna pay you like a fixed monthly fee. Is it something like that?
Yeah, it's like a fixed fee. Sometimes it's based on duration in orbit. Sometimes it's based on, kind of how often you're actually performing operations in orbit. The key is that that customer doesn't purchase the satellite hardware, and then it's not up to them how long the refurbishment cycle takes or what reentry looks like in the licensing process. They care about being in space, starting at a certain time and then for a certain duration. And so we provide that schedule certainty that I was talking about was kind of key about the launch market. In addition to the supply, you also want that schedule certainty. And so that's what we aim to provide by saying that we have a fleet of satellites that are moving up and down on a regular basis, and we can guarantee that you will have a satellite ready, very far in advance, like 12 months, or very short in advance, and then you pay a premium of, say 6 weeks or 4 weeks or 2 weeks or something like that based on payload processing. And like that is the key value proposition that we give. How people actually kind of pay for that, obviously, that's still going through a lot of customer discovery and customer
Yeah.
interaction.
Yeah, because it was, I mean, a version of that was going to be my next question. Obviously, also don't tell me anything that's commercially sensitive.
Yeah.
But it's interesting for you guys. It's basically the pricing question, right? Because so, someone who's like a traditional quote unquote traditional satellite company who's manufacturing a bus, right?
Yeah.
They know what the bill of materials is, right? And then they kind of
Yep.
decide what the market is, and but it's sort of like, well, I shouldn't say simple, but like relatively simple. For you guys, you have this really interesting element that your cost at the end of the day, if all goes well, is materially driven by how many reusers you get out of the platform, right? And
Yep.
your outcomes literally range from, yeah, 15 years down, whatever, no, actually decades down the road, we reused that platform 15 times, ideal case,
Yep.
right? But the other end of the outcome is it failed on the first one, right? And
Yep.
so if all goes well and you guys do thousands of these, right, then you can just do statistical modeling and you'll get more and more data points, right? But at the stage right now at the beginning, that's kind of intellectually a tough question, right? Like how do you price that risk and divide it between yourselves and the customer?
Yeah, so it's the way we think about that pricing is the value that's provided to the customer, as opposed to the cost of kind of goods used or goods sold. And so, like I said, we could have a customer that uses the same satellite for the same mission, but if we offer them an 18-month lead time versus a 6-week lead time, that's a very different value proposition to them, and therefore obviously a different cost. And so, or a different price, but the cost to us is necessarily the same. And so that really plays into different ways that we can price this based on the value proposition kind of to each customer. So, yeah, I think that's as deep as we can go onto that topic, but it really is more so just the bomb price plus profit kind of thing.
And then last question on sort of that business model type
Yeah.
stuff. Is there any sort of, eventually, will there be any sort of insurance angle in this? And what I mean by that is, I mean, I guess if I remember correctly, like the large part of LEO satellites aren't even insured or insurable at the moment, right? But let's say we actually get to an insurance market, then it seems that it would be attractive to the insurance companies if an asset could be recovered rather than
Yeah.
paying out the full value of the asset.
Yep. Absolutely. Yeah. I mean, we've talked to customers and insurance brokers and folks that are familiar with that world, and there's definitely some really interesting possibilities that we can open up as a result of our fleet operations and kind of full reusability. For sure, we have to demonstrate the technology and prove that it is actually recoverable in a state that still has value. But very recently, you can transfer ownership of assets in space, but there's a pretty small market to do that. And so it's not enough to insure it and say you're definitely going to get, the market value out of your satellite because there's only one other person that might buy it. That doesn't work out very well. But if you can get the hardware back, and then you can have hands on the hardware, it gets much closer to say like an asset-backed lease, as opposed to an insurance kind of policy.
Yeah.
And there's a combination between those two that you can look at. So
Yeah.
yeah.
Okay. Yeah, that makes sense. Okay. Talking about proving the capability. So, if I heard you correctly, I guess you guys are flying for the first time first quarter next year. Was that it?
Yep. Q1 2027. Yep.
Okay. And what are the mission objectives on that one? Are you going to try to bring it already back?
Yep, yeah. So that's a full re-entry mission. We've actually sold out the payload manifest. We've got multiple customers, really good cross-section of defense and commercial customers that are flying with us. And we'll be in space for approximately 3 months. And then we will come back, re-enter, deploy parachutes, land on the ground in Australia. And so really this is kind of full tech stack demonstration of, learning as a startup what we need to do to offer something valuable to our customers down the road. And it even includes how do we interact with customers, right? What's the right way to interact with defense customers and the contracts that they like versus commercial customers and the contracts that they like? What are the operations to get those payloads back from the vehicle to those customers, and what's the time it takes to do that? This mission really stress tests that whole life cycle of our business case and we'll learn a drastic amount from it that will go into our operations as well as our vehicle design.
Gotcha. And then if that first mission goes well, what are the next big milestones for you guys?
Yeah, so the next so for sure we'll fly more missions very shortly after that. And then the next big milestone is showing the reuse of that first vehicle. And so showing the refurbishment process, the reuse, the reflight, the requalification, all the things that need to go into that to show that this vehicle, can actually be reused and reflown. That's the next milestone. And so everything we learn throughout that process will go into our next generation vehicles design. And then that one, really the goal is to get the fleet up and running. And so kind of milestone number 3 on the very high level roadmap is production vehicle and fleet operations, and then it's scaling from there.
Gotcha. And so the medium long-term vision, I assume, is that you guys would operate like a fleet of probably thousands of these.
Yep, correct. Yeah,
Okay,
absolutely.
cool. Okay, let me finish off by asking you, well, there's some questions we always ask, but let me ask you a couple of different ones because of your sort of unique background of having been at SpaceX, Kuiper, Loft,
Yeah.
and now being entrepreneur. Is there anything that, I mean, these are all three very prominent organizations in the space world, and I think all three are admired. Is
Yeah.
there certain things you're trying to emulate at Lux Aeterna? And of course, I don't mean any specific technical stuff, right? I mean sort of like more on
Yeah.
a management team
Yeah.
level.
I think one of the things that I learned through that plus all my other time is that pace of innovation is kind of all that matters and capital efficiency to do that. So whatever it takes to increase the number of iterations that you can do in a certain amount of time, that is always better than dragging out that time, but maybe saving some money in some cases. Now, obviously, that doesn't cover every single case on kind of spending money, but in most cases, we try to iterate more times than kind of it was feasibly possible. We definitely still do analysis. We definitely still do our homework and design reviews. But the goal is to get to hardware as soon as possible and iterate. And that really is what kind of speeds up our arrival to the market or arrival of a specific technology. So that was something I learned very specifically at SpaceX and is well documented, people that used to work there.
Yeah. So that's interesting. So it's like, if I understood correctly, it's actually the KPI would be really the absolute number of innovation cycles in a certain time frame rather than innovation cycles per dollar or something like that.
Yeah, and I mean, what ends up happening is those two things get linked. The wrong KPI is number of iterations to success. If you want that number to be as low as possible, it will take you
Mm,
way too long.
right.
But when you increase the number of iterations per unit time, almost always that number of iterations per dollar will also be lower than the alternative case. And so, yeah, that's kind of the key.
Good stuff. Okay, and then sort of another question like that, and I'm asking that because there might very well be some listeners here who are currently at some of these companies but are thinking about becoming entrepreneurs. Is
Yeah.
what first comes to mind if I ask you what's most different about being entrepreneur now versus working at one of those companies?
The biggest difference is there is nobody that is directly telling me and the team below me what to do. Figuring out the next right move at the highest level is now my responsibility. And even, we report, I report to a board and to investors and things like that. But they look to me to say where we're going, and then they provide comments on that and feedback and things like that. But it's very linear that says that your boss tells you what you're going to do, and hopefully you do it, as well as you can when you're inside a company. But when you found a company, it's really about matching this long-term vision to the short-term execution, and being the tissue that connects those dots for everybody else to kind of execute after. So I'd say that's probably the biggest difference once I went from being an employee to being a founder.
Gotcha. Makes sense. Okay, let's get to our two usual final questions. The first one is, again, you could have done many different things in space. And is there anything else in the commercial space sector that you think is particularly interesting at this point in time that you maybe even somewhere on the side following the news, what's going on?
I mean, the biggest one that I find really exciting is, power delivery in space and kind of getting power grid. There's folks looking at kind of being above us and delivering lots of power. There's folks looking at being on Earth and delivering power, obviously wirelessly to our satellites, but really maximizing that power without having to do ginormous solar arrays, right?
Mm,
Everything that we want to do in space has more power, and big giant solar arrays are a big problem, right? So
mm.
the various approaches that are being looked at to get more power to our satellites, those are really exciting to me and definitely an unlock, in the future as we scale the industry as a whole.
And when you're saying, just one follow-up question, if you're saying big solar arrays are a problem, is that a supply chain comment or why are they a problem?
No, it's like a mechanics in space problem.
Okay.
When you have very large flat things, they're very hard to control, and they're very hard to stop those from bending
Sure.
if you want to move the thing. So that's
Yeah.
my mechanical engineer brain coming in
Yeah.
on that. And obviously those need to fold up and assemble on orbit and things like that. And that's just complexity that there's definitely people looking at, but yeah, very large arrays of solar are difficult.
Gotcha. Makes sense. Okay, final question. Favorite science fiction?
Favorite science fiction. I'll call out a recent one, which was the Red Rising series.
Oh
And kind
yeah.
of it's like, this future world that involves Mars and a very different world than ours. So yeah, that's my favorite recent. Obviously, love a lot of the classics like Star Wars and stuff like that. But that was a series that I read recently and really liked.
Did you read the whole series?
I think I've read the first two, but I don't think
Okay,
I've
yeah,
I've gone past that. Yeah.
I'm in the middle of the second one, but yeah, I endorse that one. It's yeah, it is science
Good.
fiction. It is set in space. It is societal science fiction.
Yeah.
It is dystopian, but it's yeah, it's a good one.
Yeah, it's
Okay,
good. It's not
cool.
too far off on science fiction, so
Yeah, yeah.
it's an attainable world. But great. Well, thanks a lot for having me. I've really enjoyed it. Yeah, appreciate it. Thank you.
Yeah, thanks a lot, Brian. Take care.
And that's it for another nominal episode of the Space Business Podcast. And once more, if you enjoyed this episode, please leave us a 5-star rating on your favorite podcast platform. such as Apple or Spotify. You can follow us on Twitter at podcast_space. We're also on LinkedIn under the Space Business Podcast. Lastly, if you have any feedback, including ideas for guests, and that may even include yourself if you have an exciting space story to tell, or interested in becoming a sponsor, or really for any other suggestions, you can drop us an email at spacebusinesspodcast@gmail.com. Thanks so much for listening, and see you for the next episode.